In my previous videos, you would have seen how I made the smart extension box with gesture control, or the gamer assistant project to control the RGB LEDs. They both were pretty good projects in my opinion, but they could be definitely improved in a lot of ways. So in this video, we'll learn how to use MQTT protocol to reduce latency and the size of the data that travels between our devices. So without any further delay, let's get started. MQTT stands for Message Queue Telemetry Transport. This protocol was designed for high ping and low bandwidth networks. More specifically, it was designed to carry small data fast and reliably. So this is sort of perfect for the projects I do here in this channel, and also it's a perfect protocol for many other IoT projects. So I thought it was a better idea to make a separate video on this topic so you'll have a better understanding on how it works. First, let's see how MQTT works, and also towards the end of the video, we'll see a cloud-based MQTT broker for our projects, so you can focus more on the project rather than setting up the broker. MQTT is a publish-subscribe protocol which will help two devices or clients communicate with each other through a middleware called broker. Here, each client or a device can be subscribed to a particular topic, and when another client publishes a message on a subscribed topic, the broker notifies the message to the client that has subscribed to that topic. If it's confusing, let me show you a different analogy to understand better. Consider you and me as a client, where YouTube is the broker. I publish my videos in my channel, which is the topic, and when you subscribe to my topic, you get notified from YouTube. This is almost how the MQTT protocol works. If that analogy helped you understand MQTT protocol, you should probably subscribe to my channel as well as hit the bell icon, because that's an additional weird step required in YouTube unlike MQTT. So far from the concept, we understood that we need broker which will help in communication between two devices. Now there are so many ways of setting up this broker. We can use a virtual machine, an old laptop or a PC, use an online server, use a single board computer, or use a pre-built MQTT cloud-based broker. In this video, we'll see the last two options. Single board computer. Whenever we talk about a single board computer, the first thing that comes to our mind would be the Raspberry Pi, because of its popularity and availability. For this video specifically, we'll use the Raspberry Pi 0W, because it's the cheapest option on the Raspberry Pi lineup and it can run MQTT broker smoothly without any issues. But sometimes it's a struggle to set up a single board computer unlike a microcontroller, because the initial step of single board computers need a display and a keyboard minimum. So as an added bonus to this video, we'll see how we can set up Raspberry Pi without a monitor and a keyboard. First, we need an operating system to run the Raspberry Pi. So go to the Raspberry Pi software page and download the Raspberry Pi Imager. Once the setup is downloaded, just install the Raspberry Pi Imager. I'm just going with a light version of the 32-bit Raspberry Pi OS, because we won't be needing any GUI as we'll set up everything over SSH. Unfortunately, there is no default way to connect our Raspberry Pi to a PC. For that reason, we need to set up a few things in the SD card before we insert the card inside the Raspberry Pi. We need to create a Wi-Fi configuration file in the SD card. So the Raspberry Pi connects to an access point, same as your PC when it boots up. Open a notepad file and copy and paste these lines, and change your Wi-Fi SSID, Wi-Fi password and the country name accordingly. Once that's done, save the file in the SD card root folder with a name Wi-Fi_supplicant and with extension .conf. This will help us connect the Raspberry Pi to the access point. But still we haven't set up the SSH for the device. For this, we need to create an empty file with the name SSH, and the file should not have any extension. I haven't found any GUI way of doing this in Windows, so we'll be using Windows PowerShell. Press Shift and right mouse click. Now in the pop-up menu, select the PowerShell. Here enter the command new item SSH. This will create the empty SSH file that we need. Once these setups are done, we can insert the SD card on our Raspberry Pi. We would still be missing one thing, even if the Raspberry Pi connects to the Wi-Fi and the SSH is enabled. We don't know the IP address of the Raspberry Pi to make the connection between the PC and the Raspberry Pi. Sometimes people use software like AngryIP to find the IP address of the Raspberry Pi in their network. Instead of making things complicated, we can use a command prompt or your router admin page to find that. Just check your router ARP list or type ARP-A in the command prompt in your PC before you power on your Raspberry Pi. Take a look at the list of IP in your network. then power the Raspberry Pi back on. Once the Raspberry Pi is connected to the network, you will see a new IP address pop up in your ARP list. This is the IP address of your Raspberry Pi. Now we got everything set. We can use a software like Putty to make the SSH connection to the Raspberry Pi. Here just type the IP address of your Raspberry Pi and start the connection. The default username is Pi and the password is Raspberry. With this, we have successfully configured Raspberry Pi without any additional peripherals. It might have been an off topic for a while, but I think this trick will definitely save you a lot of time and effort when working with the Raspberry Pi. So let's jump back to our topic, MQTT. Once you are inside the Raspberry Pi, first update the Linux repository with the command sudo apt-get update. Then followed by sudo apt-get upgrade. We need multiple terminals for testing MQTT, but we are using Raspberry Pi without GUI over SSH. So we won't be having the option for this. So we need to install something called tmux, which will help emulate multiple terminals on the same screen. To install, use the command sudo apt-get install tmux. Since all the setup related to the Raspberry Pi is done, finally we can start MQTT. Install the package Mosquitto, which is the MQTT broker that will be running on our Raspberry Pi. Then install another package called Mosquitto client. With this package, we can test if our MQTT broker is working properly within the Raspberry Pi. To run the Mosquitto broker, just type mosquitto-d, which will start the broker in the background. Instead of just taking my word for the broker running in the background, we can actually test this using the Mosquitto client package. So we'll subscribe to a topic and try publishing some data to that topic. Now just type tmux, which will take us inside the virtual terminal, and then type the following command in the virtual terminal, mosquitto_sub. So this will help us subscribe to a topic. So then followed by -d-t, and I'll give the topic name relay control. This will subscribe to the topic with the broker and wait for the data to be published in the topic. You can see the process is still running on the terminal. This is the reason we need to install tmux, because we can't quit this and publish the topic in the same terminal. So press Ctrl+B and press C. This will create a new virtual terminal and run this Mosquitto subscriber in the background. Now in this virtual terminal, we can publish the data to this topic. Type the command mosquitto_pub -d-t and use the same topic as before, relay control. Then we have to send the message with -m followed by the message, let's say turn on, and enter. It seems the data is published. So we can check this by going back to the Mosquitto subscriber. For that, press Ctrl+B, then press L. We can see that we have received the message successfully. As we are done with the tedious part of setting up the broker, let's see how we can integrate this with our Node MCU. For testing purposes, I will use my previous project, the Smart Extension box, instead of building a new circuit. It actually doesn't matter as the setting up MQTT part is totally generalized. You can pretty much use this in any project. Open your Arduino IDE and download the library pub sub client through your Arduino library manager. Then open the code Raspberry Pi MQTT. First change the Wi-Fi SSID and Wi-Fi password. Then change the MQTT server to your Raspberry Pi IP address. And subscribe to the topic that you would wish to listen. In my case, I subscribe to these topics. Finally upload the code to your Node MCU. In my case, I'm using the FTDI module to update the Smart Extension box. Don't worry about the code. As usual, all my codes will be available on my GitHub repo, which should help you get started with MQTT. Now it's time to test. I'll publish message 1 to the topic relay control/relay_1 in the Raspberry Pi to turn on the relay inside the Smart Extension box. You can almost instantly see the relay turns on. When I compare this to my previous builds, the latency is greatly reduced. We can also do the same to turn off the relay just by sending message 0. Now comes the big question. Do you really want to go through this struggle for MQTT in every project? Obviously not. There is an alternative, and that's where our sponsor for this video, Reyax Technology, comes. They have built a cloud platform called RYC1001. This provides all the functionality of MQTT along with their custom features, which makes the connection between the broker and your device very secure. Best of all, it's just for $15 for 5 years. It's a comparatively a good option for the Raspberry Pi because the setup charge and cost of keeping the Raspberry Pi running for 5 years would definitely be more than $15. Let me show you how it works once you have bought the RYC1001. As soon as you register, you'll get your username, password, network ID and device ID to your email. As of now, there is no GUI dashboard, but it's pretty easy to set up with the existing tools. You can also see the documentation to know more detailed explanation on how to set up their platform with Android, Windows and other platforms. There are two concepts that we need to remember when we are using RYC1001. One is the command feature and the other one is the notification feature. If you see their datasheet, when the command topic is executed, the system will save the data and generate command ID, which we can use to retrieve the data either to read or to modify using command update topic. This is one of the major advantages of using the RYC cloud over regular MQTT brokers, as we not only just send the information to the device, we also store the access time, last updated time and other relevant data which we can use later. Similarly, there is another feature called notification, which we can use to send the data frequently over a set interval of time and not store them to the cloud. You can go through their datasheet for more information about their platform and how to use these features. Instead of just taking my word about the cloud platform, let's see how to set up RYC1001 for ESP8266. Make sure you have installed the PubSub client library in your Arduino IDE and then open the code Reyax Relay Control. Here you need to update the data that you get in your mail, starting with the MQTT server, username, password and the client ID. Here the topic API request is constant. Every time we publish a command or notification, it has to be done to this topic. Similarly, you need to subscribe to one of these topics to receive the data when the topic is updated. So this eliminates handling a huge variety of topics in our MQTT broker. Finally, make sure your network ID is changed. In my case, it's 80 and for you it may vary. Once we have updated the program according to your account, we can compile and upload the code to a smart extension box. To control the smart extension box, we can use another similar RYC publish code with NodeMCU to publish the data to the topic, which is also available on my GitHub page. But I will show you an alternative way on how we can use Windows to publish the data to RYC1001 cloud. For this, download and install the application MQTT FX. Open the MQTT FX app. First, make sure M2M Eclipse is selected in the drop-down list and then click on the gear icon to update the credentials. First, change the broker address to iot.reyax.com and port to 1883, and for the client ID, use the username and a 5-digit number after that. Then click on the user credentials and update your username and the password. Finally, click apply on the bottom corner and then press OK. Now go back to the subscribe tab and subscribe to the topic API/command/80/hash. Here 80 is the network ID. You might have a different one, so make sure you change it. Now to test everything is working, go back to the publish tab and send this JSON data. This data will insert the command in the cloud and also turn on the smart extension box. If you like to see what is happening, you can also see in the subscribe tab. We can use the same command to turn off the lights. But instead of inserting a new command every time, we can update the same command. Just copy the command ID. Now go back to the publish tab and change the JSON file to update the command. Then subscribe to another topic API/command update/80/hash. Now when you publish, the command is updated and the smart extension box turns off the light. This might sound a bit complicated than MQTT, but the logic is almost similar with some additional functionality. If you have any doubts or difficulties, you can directly contact the Reyax support team. They have been such a great help in making me understand how the cloud platform works and how I can integrate their cloud platform within my projects. So if you are interested, check their product and their website. I'll drop these links in the description. With this, we are at the end of the video. I hope this video was helpful a bit in learning and setting up MQTT. And also I'm planning to include this MQTT protocol in my upcoming projects. So if you are interested in similar stuff and would like to support, hit the like button and share it with your friends who would enjoy such content. And especially don't forget to subscribe so you won't miss any of my new upcoming videos. Until next time, you can watch my other videos from the link on the screen or the link given in the description.